Okay, today on the workbench we've got the Sonicon Sonic Controlled Space Vehicle made by Masudaya in Japan, and I got to show you a picture of that close up as long as it's on the screen right there. Just take a look at that, because that's what the box looked like with the Japanese. And here's a picture of what the original whistle looked like. It's a whistle controlled toy and the original antenna. So this toy as it came to me did not have the whistle, did not have the antenna. So maybe I shouldn't have moved the camera away. Let's move the camera back. I'm going to show you one more thing before we play with the toy, and then I'm going to take the toy apart so you can see what's going on inside there. So let's get rid of this picture. And here is a video on YouTube of somebody that owned one of these years ago, and they posted it, and what I was trying to find out was the frequency of the whistle. So let's see. Let's get this running here. I'll put a link to this video down below so you can watch the whole thing if you want. So you can hear the tone of the whistle. And while he blows it, then the antenna will turn, which makes it go in a new direction. And the antenna indicates the direction it's going to go. And then here's the whistle I made. So I got the tone right. So theoretically, if he was using the right whistle with his, then it should work with mine. And I haven't tried it yet. I thought I'd turn the camera on and we'd do all this crap at once. I'm going to need more floor space though. Let's, if we move this way over here, and let's try to get as wide a field of view as possible. Get my whistle. And I don't have the toy screwed together on purpose so that I can easily take it apart. I'm trying to remember where the power switch was. Trying to get it to go forward. Well, you get the idea. You basically need to be within an arm's length of the toy. Let's move everything around for a better view. Let's move over to here. A little bit more room maybe for taking this stuff apart. So, you know, I've done videos on Sonicon toys before, Sonicon rockets, Sonicon cars, it's quite a few of them, and they all kind of work a little bit in basically the same way. But this old technology, there's no transistors or tubes or anything like that. It's all electromechanical, meaning the vibrations from the whistle are actually picked up by mechanical contacts, which then control a relay, which does the magic. Now you need the antenna, which there wasn't one of, so that you know which way the drive wheels underneath are turned, so you know which way it's going to go. Because without that, I mean, it just becomes a random guessing game. Now there's a ratchet, you can hear. So this can rotate this way, but can't rotate back that way. This is the drive wheel, and this wheel here is actually freewheeling, but they ran a little metal rod there to wedge with gravity so it can freewheel this way, and it's supposed to bind up that way. What that does is that helps the turning action when the car is in that mode. So right now, if this wheel is on this side and this ratchet won't let it turn that way, and if this is driving forward, that's going to lock against the ratchet and the vehicle's going to move in the direction that that wheel is driving it. But if this motor reversed and this wheel started turning the other way, then this whole thing will rotate. So while I'm blowing the whistle, the motor is running in the opposite direction to rotate, and when you're not blowing the whistle, it's driving forward. You got that? Good. And let's lift the body off this thing. Get the body off, and interestingly enough, this is all metal on this one. If you ever have to take one of these apart, besides the screws on the bottom that you have to remove, there is a screw, unfortunately, dead center under that sticker that you have to remove in order to get in there. Okay. Obviously Sentimi is not working, but in order for me to get it working, I had to make the whistle first, because you can't tell if it's working or not without it. And second, I needed to make the antenna so I could tell which direction it was going, so I could actually see if it was obeying my commands. And as far as the actual problems that I found in here, it had one battery contact, one of these type here, that was completely eaten away. There are 3 D cells in here, and 2 of the D cells, which give you 3 volts, run that motor in those wheels that we saw when it's going forward. But when it's doing the turning, only this back D cell battery is used. So the turning motor is running like half the speed of the driving motor. I guess they did that maybe to make it easier to control which way it's turning, and stopping where you want it and whatnot. A lot of the other toys, like the original battery operated Sonic control toy, the Golden Sonic, which was made in America and patented in America first, it actually used 4 batteries. So it had 3 volts for the forward and 3 volts for turning, and it used a slightly different relay setup. So the way this works is this thing here, which is sitting on springs. See, it's isolated from the frame with springs. There's a metal diaphragm in there. Now the metal diaphragm has a resonant frequency, and then this plastic tube also forms the chamber for the resonant frequency that the whistle is trying to match. So when you get a tone that matches the resonant frequency of this device, that piece of metal is going to be vibrating. It's going to be vibrating ever so slightly. But if you look in there, you see that little bent piece of metal pushing down on what looks like a piece of black in the middle? Those are actually 2 switch contacts, and here are the 2 wires. Now normally when this toy is just sitting like this, those contacts are touching, which turns on this relay. So normally when you turn it on and it's moving forward or whatever direction, this relay is on, those contacts are touching. It's when the vibrations happen on that diaphragm that the contacts start opening and closing. And when they open and close, the relay then relaxes enough where it goes to its normally closed state, which means no power. It has some contacts that are closed. Remember when we first turned it on, nothing's happening, the relay's engaged, so actually the normally open contacts are the ones that are closed. You've got a common, a normally open, and normally closed. So that's how they're doing that. And as far as getting the power down to the motor, since it has to spin, there are 2 wiper brushes. There's one here and one here. And then the motor unit has 2 rings that go all the way around that pick up the power so that the motor can get power no matter where it's turning to. And here's the little ratchet. That's right there. So, all in all, it's a very basic, not super complicated. I've done a lot of videos on 3D printing them, making them. I've even made them using parts from the dollar store. And then I've also done Sonicon ones that use linear electronics instead of the mechanical sensor. In other words, a microphone and tone decoding circuits, and digital versions. But a little bit of a pen schematic, if you will. So basically got your 3 batteries up here, and these 2 batteries, you've got the negative of that first group goes through that vibration switch back here, which is normally closed, So that means this relay is getting negative from there. And then this side of the relay, this is the power switch in the front that turns the whole toy on and off. When you close that, that again puts the 3 volts because you've got 2 batteries. So this coil in the relay is energized, turned on. So that means the normally open contact is closed when you first turn the thing on without hearing any whistle. So that means if you take the way they have this wired, they have the normally open going to the negative on one side, and they have the common coming down to the motor that's driving the wheels. Then they have the other side of the motor going to that same switch point, which is getting the positive 3 volts. So when you turn it on, this is energized, this is closed, this relay's down, the motor's running. As soon as this starts vibrating and opening up, this relay no longer stays in the closed position. DC relays don't like AC voltages. They like DC. So as soon as that starts resonating, this thing will open up, and then all of a sudden the normally closed contact, which goes clear over to that last battery I was telling you about, gives its positive, which goes through the common down to the motor, and this side of the motor was already connected there, so you get the 1.5 volts running the motor in the opposite direction. And that's how this particular Sonicon, let's get the whole name right, Sonicon Sonic Control Space Vehicle, that's how it works.